And so here are our current challenges. And first one is image distortion from the camera. Like while I am experimenting with some other data from some other people who are already work on this type of fields, mostly on the research purposes. So they are actually using distortion matrices to like to remove the distortion from the image, or the like for the video, like the for the each of those frames, those distortions came from the camera. Okay, I don't think so we can do that, because like Mr. Sohn actually collected those videos from various type of other people's from their cars. So I don't know like whether we can actually able to like collect the distortion matrix from them. And next is color selection and thresholding. And in color selection and thresholding is a very important part of our main task, because in various type of like regions in India, like in the roadsides, like those like landmarks are actually not so well defined, and like their carry and their colors are like actually like also very varying. So we have to think of any kind of adaptive color selection methods or thresholding methods, so that like we can be able to like create our binary thresholding binary thresholded binary image maps, so that we can be able to detect the edges and do some other processing to detect the lanes. Okay. In that part, we are actually only processing the all of our operations into some selected regions. So and actually experiment with that thing, and Olaf a lot with those videos provided by Mr. Suman, and we saw that like we actually like for some cases, if we actually broaden the region of region of interest, we're actually getting a very good results. But some cases, if we actually going to if we reduce the size of the ROI part, then we actually like also get good results from those previous ones. Okay, so like from like it actually depends on the video. Okay, like what type of environment, or what type of things are already put it in the video or something. Transform. I think Mr. Ahmed actually implemented that one, but I think we need to improve it more, because pulsation transform is very much useful for carbon detection and some other parts also, like which will be taken care from future like prospect or something. And another thing is averaging and extrapolating lines for multiple lane detection. Okay, and I know like Mr. Suman actually and Olaf also like talk about that problem in which like there are a lot of lines which are actually kind of oscillating, and yeah, and sometimes lines are also going crazy, like talking like they're actually going parallel, or in some cases they're actually goes out of the scene or something. So in that cases, we can actually use averaging and extrapolating lines. So that thing actually like whenever it actually detects a lot of lines in a same orientation to the lens, so we can actually average them, so that like those oscillatings and all of those things can be handled. And Kalman filter also do that kind of thing. Okay, and extrapolating line is that let's say we know like in the some part of the roads or something, there may be not well defined lane lines. Okay, so in that cases, we are actually not getting those lane lines very like perfectly or something. So in that cases, we can actually extrapolate those lane lines to the next frame, so that we can actually get those error values which can be used for the Kalman filter. Okay, and it is very much useful for multiple lane detection. Okay, in the next slide, yeah, sorry. Okay, another thing is polynomial field. It is actually will be used for carbon detection. So polynomial field is kind of a operation which is we can actually say like okay, let's say like for the lane detection, like if we are actually slice the whole ROI part into some horizontal section and do the hop transform, so that so in that cases we actually going to get some kind of segment of lines of segments of pixels which are actually contributed to the those lanes. Okay, so now we have to like it's maybe second curve, polynomial curve. Okay, so in that way we can actually able to do the curve length direction. Okay, next slide. How can we improve our model? So yeah, I actually look into some other papers and some other tutorials or something, and I actually get one good method which is lane regression using Ransec algorithm. And in the lane regression, that is actually is a very efficient method. I think we need to use this in our model because like in the some previous cases, like I actually already mentioned it, like there may be some cases where like there are not so well defined lane marks, or maybe it is discontinuous or something. So in that cases they actually the lane regression using Ransec algorithm actually kind of fitted a line across those pixels for like let's say it actually picks some of the pixels from the lanes to the like towards color thresholding or some other noises. It can be able to detect the whole lane. Then lane regression can efficiently regress it can compute a line which will be like it's around it may not be perfectly fitted to the main lane, but it actually its orientation will be around pretty much the same around the main regression line, so main lane line. Okay, so and Ransec algorithm is a very popular algorithm which is basically used for fitting the baseline in the regression for the regression process and removing noise from the edges marks. It is another process to remove the noise from the edges marks. And perspective transform for the polynomial fitting. It is actually a process to for the polynomial fitting in the perspective transform. Okay. Here are some samples. It is the polynomial fitting second order using perspective transform. So you can see it's a perspective transform of a curved lane, and those lines I actually zoomed it and then copied out. So there's the detected lane line for the polynomial fitting of second order. Okay, and here is the curve lane detection. You can see like that curve, like the main lane curve, but we actually figured second order, so that's why we're actually getting this kind of line. But it's okay, like because if we are actually reduce the ROI part, like in that type of region, we can actually get pretty much a good result, and that is like denoised thresholded binary image, which actually not from the Indian the videos from Indian roads. Actually took it out from some other videos from the internet. Okay, so that actually uses that kind of that algorithm which I actually provide that process which I actually mentioned earlier. And thank you. Any questions?